Welcome to Lesson 4 of the Ruby on Rails tutorial screencast, Rails Flavored Ruby. In this lesson, we'll take a short break from developing the main sample application to learn some of the aspects of Ruby most important for understanding Rails. To get started, let's take a look at some of the code from the last lesson. I'm going to look at the layout. This is in app views layouts, application.html.erb. So for now, I'd like to focus on this line here. So let's go from left to right. This is style sheet link tag. What is that? Well, it turns out this is a Rails helper. This comes defined as part of the Rails framework. So helper is a function, but if this is a function, where are the parentheses? Like here we've got yield with the parentheses. And it turns out that in Ruby, parentheses are optional. Here we've got colon title. Here we've got media colon. Are those related? And the answer is they are. They're both related to symbols, and we'll talk about exactly what their relationship is in this lesson. And finally, we've got media colon all, data turbolinks track, and then this weird symbol here. True, what is this thing? It turns out that this is what's called in Ruby a hash. So you can see that there's a lot going on here. And this is just stuff that's built into Rails. We also want to be able to define our own things. For example, this is a built-in helper, but we want to be able to define our own helpers as well. And the motivation for this involves this title here. So let's fire up a server. Let's open up the page. So you can see here in the tab it says home, and then it's got the vertical bar character, this pipe, and then the base title, Ruby on Rails tutorial sample app. And that's coming from here. But what if we wanted this title on some pages to be blank? So for example, this is actually the design we're going to adopt on the home page. We're going to get rid of this. So actually, let me fire up guard too. We'll see this go red. So this here is providing this title that's being yielded here. So what if we save this? This should go red. But I'm going to look at this and refresh it. So you can see that if we get rid of that per page title, there's still the base title, but then there's also this leading pipe character. And we don't want that. What we want is just the base title. So to do that, I want to define a helper called full title that goes in app helpers application helper. There's also a static pages helper that got generated as part of Rails generate controller, but this is for helpers that are specific to the static pages. The helper we're about to make, in fact, is going to apply to any page on the site. So let's define this. I'm going to start with a comment. Here's the function name, also called a method name. It's called full title. I'm going to have a default, which is just an empty string. Let's give it the base title, which is, we can just copy it here. It's from here. And if the page title is empty, then I want to return that base title. Otherwise, I want to add that page title in, like this. So if this is confusing, that's the whole point. The whole point of this lesson is to understand things like this, to understand the stuff that's in here with the style sheet link tag, and understand how to make a method like this, and how to understand all of the elements inside it. Let's put this thing to work, though, just to verify that this actually accomplishes the goal of getting rid of that pipe character. So let's restore this, get back to green. I want to change our test up here. So this is test It's, where is it? It's in controller, static pages controller. So what we want is instead of home, pipe character, base title, we want to just get rid of this here. So this should go red. And now we want to put this full title helper to work here. So we've already got the per page title here in this yield. So let's do this, full title. Get rid of this here. Save it and see if we're green. Nope, we're not. Why didn't that work? Oh, it's because we haven't changed this. We're still providing the title. The tests were right. So at this point, we've now replicated our previous result. In fact, we can, let's just Command Z this. So this should be green because now we're just using full title to replicate our previous behavior. So now let's do this, change it up, go red, and then we can either do this, just make it blank. That'll work. But because of the default that we defined, and we'll be talking about that in this lesson, I can just get rid of this. There we go. You can see here, if you refresh, there it is. So there's the title. It's just the base title. There's no leading pipe character. From looking at these examples, I hope you're convinced that it's worthwhile to learn enough Ruby to understand what's going on here, and that's the purpose of this lesson. First, I want to talk about two of the most important aspects of Ruby, strings and methods. Before we get started, I want to make a comment about comments. Go over here and look at the helper that we defined. This here is a Ruby comment. It starts with this hash sign, also called a pound sign or an octothorpe. There's also a multi-line syntax in Ruby for making comments, and it's so rarely used that I don't even remember what it is offhand. I would have to Google around to find it. So almost all commenting is done like this. So that's the first aspect of this method. But then the rest of it involves methods and strings. So those are two of the most important things in Ruby, especially for web development. Our principal tool for learning Ruby will be the Rails console, which we've seen a couple times before. There are actually a couple of things that annoy me about this prompt. For one, it gives too much information. It's got the Ruby version, which is exposed. There's no reason to do that particularly. Certainly for this tutorial, it won't matter. It has the line number here. If you hit return, it exposes the line number. And it also did this indentation. That's really weird. I don't know what's going on there. So we do if it's indenting. And I don't like that behavior. So I'm going to make a couple of edits. This is the kind of thing that's optional, but I think it'll make things more convenient. All right, so I'm just going to paste in some stuff from the tutorial. The way to do this is with a configuration file called irbrc or .irbrc, and there's an easy-to-use text editor called Nano that I want to use here. The tilde there is just the home directory. This doesn't really matter in terms of understanding. Just if you just copy what I do, you'll be fine here. This is not the core part of the tutorial, but it's important for the screencast especially to make things look nice. Let's copy the configuration there from the book. And you can see the menus here. If you've never used Nano, just look at the menus. It says Control X for exit, and then we want to say yes to modify the buffer, and that file name is fine. Okay, so now let's boot up the console again. We can see now the prompt is simpler. It's just these two characters. It's a simple prompt, and if we do like if, we'll be talking about if statements, but now it doesn't have the indentation. Good. All right, with that configuration done, let's start talking about strings. In order to talk about the console, I'd like to maximize it. Almost everything in this lesson will involve the console, so this is going to be convenient for us. So let's talk about the two fundamental kinds of strings. There's the empty string, and then there's everything else. So the string is not empty. Strings can be combined together using the concatenation operator plus. Foo plus bar is just foobar. Incidentally, this foobar here is a very commonly used thing in computer science, and in fact it's not related to this. At least probably not. There's a footnote in the tutorial about this. There's another way to combine two strings together, apart from concatenation, called interpolation. So let's introduce a variable, call it first name, and assign a string to it. Now we can interpolate this into another string like this using the pound sign and then open curly brace, then the variable, and this will just insert this value into the string. We can also define another variable for the last name, and just go up arrow a couple times and do this. So this is my preferred way to combine these two things together. You can also do this. Well, so you'd be tempted to do this, first name plus last name, but that doesn't work because it doesn't have a space. So you have to do this here. I find variable interpolation or string interpolation much more natural, so this is my preferred syntax here for this sort of operation. One common task when doing interactive Ruby or when writing Ruby scripts is to print something to the screen. This actually isn't all that important in Rails, but it's so common that I think it's important to cover it here. The main way to print things in Ruby is called puts, also pronounced puts. And you can see what this did was actually print out foo to the screen and then return nil. So nil is a special Ruby value for nothing at all. It's a contraction of the Latin word nihil, which means nothing. There's a closely related function called print. And the main difference is that print doesn't have a new line at the end of foo. It just sticks it on the screen. If it were up to me, I would have reversed these two. I think print should put a new line and puts should not, but this is the way it is. It's been this way since the beginning. We can replicate the behavior, by the way, by putting, a literal new line, backslash lowercase n. This is now the same behavior as puts. Now you may have noticed that I've been using double quoted strings, but if we look back at our original code, let's take a look at this. Actually, why don't we take a look at the configuration from the last lesson. There's some advanced configuration. It doesn't matter if you follow this or not. I just want to show you. This is the test helper. And so here's an example of single quoted strings here, and then now there's a double quoted string. Sometimes people wonder why is it that people use one or the other. And the answer is that this is the way Ruby is. People write Ruby using double quoted strings and single quoted strings kind of haphazardly, because most of the time it doesn't matter. So they're used interchangeably. But there is one context in which there's an important difference, which is that single quoted strings don't allow for interpolation. Single quoted strings are raw strings. So for example, we can do this. Well, actually, let's just up arrow. So here's first name, last name. That's Michael Hartle. But what if I use single quoted strings? Now it just returns literally what's inside of those strings, or what's inside of the single quotes. And because this syntax here would ordinarily be interpolated, and because the return value here uses a double quoted string, they're escaped out with this backslash. So you could actually just write this, and copy this here. This is the same thing. But you can see that it's more convenient to do this because you don't have to escape things out. I mentioned that we're going to be talking about methods, and more specifically, we're going to talk about objects and message passing. So let's take a look at an object. We've seen lots of examples, it turns out, because everything in Ruby is an object. A string, among other things, is an object. And what we can do is we can call methods on it using the dot notation. In this case, I'm going to call the length method on the string. This is also called passing the length message to the string, or to the string object. It's also called sending the length message to the object. So no matter what you call it, the answer is 6 because foobar has length 6. Let's look at another example. We can send the empty question mark method. I sometimes anthropomorphize these variables or these objects and say we're asking foobar whether it's empty or not, and the answer is false. But the empty string is empty. And we can also write it like this with single quotes. This kind of method here with a question mark at the end is called a Boolean method because it returns either true or false. And these kinds of methods are especially useful for control flow. So let's give an example of that. Assign a string to assign a foobar to this variable s for string. And I'm going to say if s is empty, then do one thing. I'm going to return string is empty. Else, I want to say the string is non-empty. And as you might have expected, it printed out, or rather it returned the value, the string is non-empty. Notice there's no putS here. This is actually returning this value. It's not printing it. It's a subtle distinction, but it would be returning nil and printing this to the screen if we'd done putS. If we want to include more than one clause, we can use Ruby's else if. Say if s is nil, if s.nil question mark. Of course it's not. Else if, see the middle E disappears for some reason. S.empty. Else if s.include question mark. Checks for a substring inclusion. And then we could put an else here if we wanted to, or we can just end it. Let's look at some other examples of what Booleans can do. And in this context, I wanted to find a couple more variables to make them short. So x is the string foo, y is the empty string. And now I want to print out both strings are empty if they're both empty. Notice that we can put the if statement at the end here. This is actually fairly unusual. Most languages don't allow you to do this, but Ruby does. So if x.empty question mark, oops, and y is empty, y.empty question mark. So think about what this is going to do. Well, x is definitely not empty, y is empty, so this is false and this is true. So false and true is false. So we want both of them to be true, but only one of them is true, so this returns nil. And in particular, it doesn't put this out to the screen. Let's change this up here. One of the strings is empty if x is empty or y is empty. So or is double pipe. Lots of languages have the same syntax, so if you've programmed much at all, you've probably seen this. Here, print it out, one of the strings is empty. Wow, look at that triple click. It selects the whole screen. One other particularly important operator is the not operator. Actually, I can do a single quote. Why not? So putS x is not empty if, oops, actually the tilde in some contexts does mean not, but not here. It means we need to use bang. The exclamation point is where it is bang x.empty. And because x isn't empty, it prints out x is not empty. I mentioned before that everything in Ruby is an object. That includes nothing. Nil is an object, which means that we can pass messages to it. This is a really important method. It's toS. This converts the object to a string. In this case, it's the empty string. So nil itself is not empty. You can see that it says no method error, undefined method empty for nil. And nil is its own class. It's the nil class. We'll talk about that a little more, this idea of a class in this lesson. So we can't ask if nil is empty, but we can ask if nil.toS is empty. And calling multiple methods like this is called method chaining. There's a special Boolean method for testing if an object is nil that's quite important. You might be able to guess what it is. It's nil question mark. And of course, foo is not, the empty string is not. So you might guess the only thing that's nil is nil. We saw before this if at the end of the statement. Here it is, put x is not empty if not x.empty, or if bang x.empty. This if not construction can be converted to the equivalent unless. All Ruby objects have a Boolean value that you can extract by doing not. So you can do not x.empty. That's true because x isn't empty, but x.empty itself is false. So if you negate it twice, not false is true, not true is false. Now in this context, there's no reason you would do bang bang x.empty question mark, because this thing, this empty question mark, already returns a Boolean value. But this is nice for testing things like a string. Gave me a warning here, but that's not important. What is important is that it returned true, which is to say that the string foo is true in a Boolean context. Now there's something here that's going to surprise a lot of people if you haven't used Ruby before. There are in fact only two things in Ruby that are false. There's false, of course. It evaluates to itself. Bang bang false is false. Nil is also false. So in a Boolean context, nil is false. But everything else is true. In particular, something like the number 0, which is false in a lot of languages, is true in Ruby, as is the empty string and pretty much any other empty object. I say pretty much. Everything else. Every empty anything. Empty hashes, empty arrays, empty anythings. They're all true because the only things that are false in Ruby are nil and false itself. Of course, we can't get very far without being able to define our own methods. We've already seen some examples of that here. We've got, say, the static pages controller. These methods were generated, these two, but then we defined an about method here. And then in this lesson, we've already defined a helper method. So this is using the def keyword for defining a method. So let's see how that works at the console. Ordinarily, you wouldn't define methods at the console, but for our purposes right now, this is convenient. So let's define a new method. Let's call it string message. What this is going to do is print out a message based on whether the string is empty or not. This is just, for example, this is not a great method name, but that's okay. This is just to illustrate a point. So it's going to take in the string, and I'm going to say the string has a default value of empty. So let's say if str, which is this parameter, is empty, then I'm actually not going to print it out. I'm going to return it. This will also return a string. Now, if you've used other languages before, you might expect something like this. You might expect that Ruby would return values by actually using the return keyword. And this will work. Ruby does support return, but it also will just implicitly return whatever the last expression is. In this case, this string, else this string. So you can end there and end the method. So this end ends the if else, and then this end ends the actual method. The output here is not important, and this is Ruby version dependent. What is important is that we've now defined a string message. Let's print it out. The string is non-empty, that's true. What about this? It's an empty string, that's also true. And what happens if we do this? So this is what happens when you give it no parameters, the default takes over. So since the default is an empty string, it puts out that it's an empty string. It's also worth noting that this parameter name, which I called str, is internal to this method. So we could have called this anything. As long as these two things matched, it would have had exactly the same behavior. At this point, we're in a position to understand the title helper. Let's go take a look at it. It's in the application helper. Let's just work from the top down. This first line here is, or really the 0th line in a sense, is a comment. Here we've got a function definition or a method definition, the name of the method, full title. We've got the page title parameter, or an argument, as it's also called. It has a default value of the empty string. And then we define another variable here, the base title. If the page title is empty, we just return the base title. Remember, implicit return. We could do this. So it would work just the same. It'd be exactly the same thing. In fact, we could even test that out. Let's save this here and run the test. So you can see we're still green there. So we've got implicit return here. And then in this line, we've got variable interpolation or string interpolation. If the page title, then this is just a literal pipe character, and then the base title. So that's everything in this file, apart from the top line, which is the module application helper. We'll be talking about modules later in the tutorial, especially in lesson 8. But what's important to know at this point is that when we define a method in this application helper module, it's automatically available in the views of our application. The most important data structure from the perspective of web applications is almost certainly strings, but Ruby has a lot of other data structures that are useful when writing web apps. So let's take a look at some of the examples. There are a couple of closely related data structures called arrays and ranges. If you've programmed before, it's likely that you've encountered arrays. Let's get to an array using one of my favorite methods for manipulating strings called split. So let's do foobar and then put some extra spaces in. Oops, and I want baz here. So these are 3 strings. Well, it's actually 1 string, but there are 3 internal strings separated by white space. So I want to turn this into an array. I can use the split method for this. By default, split splits on white space, so this run of white space is the same as this here. In fact, we can do other stuff. We can put in a tab character. It's not just spaces. You can split on other things if you want to do this. Just separate these by the letter X. So in this case, we do split on X. And I'm just as likely, I think, to type this. Again, in most contexts, single quoted and double quoted strings are the same thing. So split converts this string into an array. So this is the Ruby notation for an array. This is an array of strings. Got square brackets, open square bracket, close square bracket. We can define arrays literally like this. Ruby arrays are 0 offset, which is to say the first element is accessed using the number 0. This is a common source of confusion. even for someone who's been programming forever. See, even there, it's like I want the third element. The third element is this. We can also pull out negative elements. See if you can guess what -1 might be. Here's A. So -1 just starts from the end and goes in, so that should be 17, right? Arrays are self-evaluating. If we just put it into the console, it returns itself. We did A of 0, like this. We can also do this. If you get tripped up by the numbering, you can say A dot first. You can also say A dot second. A dot first is part of Ruby. A dot second is part of Rails. So this is an enhancement that Rails adds to Ruby, at least as of this moment. In fact, occasionally Rails will add new syntax to Ruby. Ruby's so flexible you can actually add syntax to it. And what's actually happened is that Rails has added syntax to Ruby, and then it's been incorporated into Ruby. But at this moment, second is not part of Ruby. There is another method that's convenient. You can see what we're doing here. We're passing a message to A, or we're calling a method on A. So A is an object, like everything in Ruby. So A.last is now the last element. So first, second, last. In this case, that's the whole array. We saw before that we can pull out the last element using a negative index. A of -1 is the same as A.last. And here I've introduced the double equals operator. This tests equality. Be careful, it's very different from this. This does an assignment, and in fact, this assignment is not valid. When it's possible to call a method on a particular object, sometimes we say that that object responds to the method. So in that context, we can say that A, which is an array, responds to length in much the same way that a string responds to length. So A.length will return the length of the array. So let's just look at some comparison operators here. X is equal to 3. It's not equal to 1, so this should be false because it's not equal to 1. Bang equals or not equals should be true. Can do greater than or equal to 1. That's true. And x is not less than 1, so this should be false. So that's pretty much the full suite of comparisons. Of course, there's greater than and less than or equal. Arrays respond to a huge number of methods that you can find out about by Googling for the Ruby API. And if you don't know what API means, you can Google for API. So let's look at some of the other methods. Just like strings, A responds to empty. So A.empty here is false because A is not empty. But we can do this. This is the empty array. That is true. We can ask the array if it includes a particular value. Does the array include 42? The answer is true. It does. We can also sort the array. Let's do this here. So this will sort it in ascending order. We can reverse arrays. We can shuffle them. Just randomizes the elements. But you might notice that after all those operations, in fact, A remains unchanged. So we can do A.sort. So sorting the array actually returns a new value. It doesn't actually change the array. If we want to change the array itself, we can use what's called a bang method. So methods that end with a bang have a couple of different meanings in Ruby and Rails. One of them is to indicate that the method in question actually mutates the variable. So A.sortBang will actually change what A is. So you can see now that's actually updated what the values are inside of A. Another useful operation is pushing a new value onto an array. So we can do that with push. Let's just push the value 6 onto this array. Probably a more common syntax, though, is to use what's sometimes called the shovel operator, like this. So that just did the same thing as push. And one of the reasons this is nice is because it's compact and it can also be chained. Of course, push can be chained too, but this is a nice way to write things. You can say let's just push foo and bar, these two strings. Among other things, you can see from this that Ruby arrays can have values with different types. Here we have integers, and technically they're actually fixed nums, and then we've got strings here. So we can mix these different types in one array. We saw before how we could split a string to form an array. The inverse of that is joining. So in this case, we just join on nothing. It just puts them all together. We can also join, say, on comma space. By the way, I said that join is an inverse of split. It's actually not quite true, because when you split on white space, you're throwing away some information. So in general, it's not possible to invert split. But we can come pretty close with join. There's a closely related data structure called ranges. Let's take a look at some examples. We're going to go from 0 up to 9, and it just evaluates itself. So what is this thing? Well, it can be best understood by turning it into an array. That's with the toA method. Remember, we saw 2s converted something into a string. This converts it to an array. But this actually gives us an error because, as I mentioned briefly just a moment ago, a number like 9 is actually a fixed num. And fixed nums do not have a toA method. There's no way to convert an integer into an array. And so what's happening here is that this dot is binding more tightly than this range. So what Ruby is doing is trying to evaluate this thing. So in order to get it to evaluate the range and then call toA on it, what we need to do is use some parentheses. So let's do that. So let's put this in parentheses, and this should give us what this range is in terms of an array. And there it is, 0 up to 9. There's a particularly useful way of making a literal array of strings. I like this a lot. This is %w, and then you can do it like this. That's a lot less typing than putting in all of these quotes by hand. By the way, I like to use these square brackets because that's what arrays use, but in fact, other things work as well. You can use curly braces. Sometimes you'll see this. I think you can even use parens. Yeah, those are all equivalent, but I do prefer the square bracket convention because it matches up. One use of ranges is to pull out a range of values. So let's do this. Let's say the 0th value, which is the first. It's confusing. Up to 2. So think about this. How many elements is this? It's actually 3. It's 0, 1, and 2. Foobar Baz. Sometimes you might want to pull out all of the values up to the last value. So let's make a longer array. So this array is just made up from the range. So suppose we wanted the element in the array from the second index, so this is the third value, up to the end. So we can say, well, it's going to be the length of the array minus 1. So the length is 10. So we can do that. The length is 10, so we're going to select from 2 up to the length minus 1. So that goes from 2 up to 9. But remember that we can get the last element out with the -1, the -1 index, like that. And this works in this context as well. So 2 dot dot -1 selects to the end of the array. Incidentally, ranges aren't just good for numbers. They work with characters as well. So say A up to E, turn it into an array. I turn it into an array, which means I need to put parentheses, because otherwise it just self-evaluates. It's not very useful, right? But if you want to see that it's working, we can do toA, and there's the array, A, B, C, D, E. Arrays and ranges and a lot of other Ruby objects respond to methods that accept what are called blocks, which are one of Ruby's most powerful features, but also one of its most confusing. So let's take a look at some examples of blocks in order to understand how they work. Let's start with the range, 1 dot dot 5. That's just 1 up to 5. Now suppose that for each of these elements we wanted to print out twice that value. So the way to do that would be to iterate through this range and then print out 2 times each value. In Ruby, we can express that by saying 1 dot dot 5 dot each, and then we're going to use a curly brace, and we're going to put a variable in these vertical pipe characters. And now we have a local variable called I, and we can print out twice that. So multiplication is just asterisk. And there we go. So you can see that this each actually returns the range, but in between it printed out each of these values. So this thing here, everything inside the curly braces, is a block. And what's going on here is that each method that we're calling on the range accepts a block argument. So this block is going into each, and then each is actually executing this. It's calling the block inside of each. There's a second equivalent way, or almost exactly equivalent way, to indicate a block, which is with the do keyword, so do and then the name of the block variable in this case. Different blocks take different numbers of variables. In this case, it's just 1. So 1 up to 5 dot each do I. Do the same thing, just double everything. So this kind of block is using do end, and it has the same effect. In this case, the contents of the block are just this thing here. It's just one line, so it easily fits here. But blocks are often multi-line, and the convention that I use, which is a common convention in the Ruby world, is to use curly braces for single-line blocks and do end for multi-line blocks. This is a quick example of a multi-line block. Let's just up arrow. Let's print a separator. There we go. This could be done in one line. It actually, let's do this. You can put a semicolon in here. This is a little confusing, but just to show you what can happen. You might see this in other people's code. I won't ever use this in this tutorial again, but a semicolon can be used to separate statements. But this style is generally much less clear, I think, than this. It's a lot clearer. As I mentioned, blocks can be quite confusing, and I really think the best way to learn about blocks is just to see lots of examples. Unless you've done a lot of programming, it's likely that you never encounter anything quite like a block. So in that spirit, let's look at some more examples. There's a times method that you can pass to an integer. So it's 3.times. Let's print out the word Beetlejuice. All right, this is just hanging, and I was confused. I thought, what is going on? Why isn't this working? And the answer is because I forgot the closing quote right in here. So let's Control-C this to quit and do this here. Here we go. Now we'll print Beetlejuice 3 times. Beetlejuice, Beetlejuice, Beetlejuice. Another example is one of my favorites called map. So suppose we wanted to take a range, 1 up to 5, and construct an array consisting of the squares of each of those elements. So you could do this with an auxiliary variable and each, but map is the best way to do it. In fact, let's do that. Let me just do it the long way. You can say squares is the empty array. 1 dot dot 5 dot each. What we can do is, for each of these guys, we can say squares, remember the shovel operator to push something on, and then I squared. So I, and Ruby uses 2 asterisks for square. So there the squares is 1, 4, 9, 16, 25, so that's great. But there's a faster way to do this, more compact, using the map method. So instead of defining an extra variable, we can do this. 1.5.map, and then the same block. So rather than doing squares equals empty array and then using the shovel operator inside of the block, we could just do something like this. If we wanted a variable, we could just assign it like that. We can look at a couple other examples of map. I'm going to map onto a literal array of strings. Remember, %w returns an array of strings like this. So suppose I wanted to calculate the uppercase version of this. We could just make an array, rather, of the uppercase versions of these. So let's do, remember, this variable here can be anything, so I'm just going to call it char. Ordinarily, I might use the letter C here for character, but I don't want to confuse it with this. It would still work, but it would just be less clear, I think. So there's an upcase method on characters. We can do the opposite. Complementary downcase method. Oops, I did something wrong there. Oh, I forgot to put the W there. So let's get that to work. There we go. By the way, there's a shorthand. Actually, I don't like this space. Oops. I'm really very detail-oriented when it comes to these things. There we go. So there's actually a way to handle this case where we're calling the same method on every element. There's a compact notation for this. Let me just show you that. So instead of this, we can do this. Array.map, we're about to talk about one of these elements. So I'm going to put an ampersand. This is weird looking syntax, but you could do ampersand and then a symbol. It's not that. Downcase, that's the name of the method. So downcase, downcase. This is the same thing. Now, the reason I mention this is that this notation, which is equivalent to this up here, was actually introduced by Rails. I mentioned that Rails sometimes extends Ruby. So this used to be a Rails extension to Ruby, but people liked it so much that it's now part of core Ruby. So I've just mentioned symbols, and we also saw hashes briefly before. These are two of the most important data structures in Rails. They're very commonly used. So now I want to talk about first hashes and then symbols, and as we'll see, they're actually very closely related to each other. Let's start by defining an empty hash. Now, since we were just talking about blocks, you might look at this and say, wait a minute, that looks like, I don't know, an empty block. And it does look like an empty block. It's really confusing. Unfortunately, Ruby uses exactly the same notation for hashes as it does for blocks in terms of these curly braces. But because there's not a variable in here, because there's not a function, I'm not actually exactly sure how the Ruby parser tells the difference between the two. But it can be confusing when you're just learning. So this is an empty hash and has nothing to do with blocks. We saw before things like arrays, like this. We can pull out an element of the array, like this. So this essentially associates an integer index, with some element in the array. So you can think of hashes essentially as a generalization of arrays. And in fact, in some languages, especially Perl, they're called associative arrays. So essentially what they are is like arrays, except instead of being restricted to integer indices, we can have things like strings. So for example, here user of first name is equal to Michael. User of last name is Hartle. Put it in a string. And now we can pull out this value like this. You can do this. I'm just going to copy it and paste it. And similarly for the last name. So this is a lot like an array, except instead of 0 or 1 or 5, we're using a string. Here I've built up the user by using this index and putting a string in, but there's actually a literal way to do it. This would probably be more common in this sort of context. We can set user equal to a literal hash. And in this context, we need to associate this first name string, which is called the key, with the value using what's called the hash rocket operator, this thing. So in this case, the key is first name and the value is also a string. And we can do the same with last name. And now this will just evaluate, and you can see it returns the hash. And the way that the interactive Ruby interpreter, which in this case is running as the base of the Rails console, displays it as it just takes out the spaces here. I'm not sure why these spaces are conventional. It's been around for a while though, so this is just a convention in Ruby is to put spaces after the open curly braces and the closed curly braces, or before the closed curly brace. Now, using strings in this context works just fine, but in fact, this is not idiomatically correct Ruby. Ordinarily, instead of string keys, you would be using symbol keys. So let's talk about symbols. Most programming languages don't have something like symbols, so Ruby symbols are a common source of confusion. They're really not that hard though, because what they really are is just like a string, except without all of the extra baggage, without all of the extra structure. So a literal symbol might be written like this. It starts with a colon and then just has some characters. So what do I mean by it's like a string but without all the baggage? Well, let's split a string. Let's split it up into its components. Let's put it on the empty string. This will give us an array of the characters. So what happens if we try to split the name symbol? No method error. Similarly, we can reverse a string. We saw how to reverse an array before, so we can reverse a string, but if we try to reverse a symbol with the same characters, no method error. There are some characters you can't use in symbols, so let me show you an example of that. We saw foobar, but if we put in a hyphen, that won't work. I actually don't know offhand which characters are allowed and which aren't. It's the kind of thing that I would ordinarily drop into Google. But if you stick to letters and numbers, you should be safe. One of the main uses of symbols is as keys and hashes. Because symbols don't have any other structures, they're just labels, it's easy to compare them to each other. So it's in particular, it's very fast. So they are really ideally suited for use as keys and hashes. Let's go up to our hash. So the idiomatically correct way to write this in Rails, so the variant of Ruby used by Rails would be like this. So this would be, last name, the colon there, and this would be first name. I did more work there than I had to, didn't I? So this is probably the second most common way to write something like this. This was the only way to do this in Ruby 1.8 and earlier. But there's an alternate syntax that is also very common and is probably more common in this context. So let's take a look at that. I'm going to actually make this, let's call it h1 for hash1. There's a second way to do this. Actually, let's start off with h2 so I don't overwrite it. So as of Ruby 1.9 and later, what you can do is not use the hash rocket, but instead use a colon at the end and take it off from the beginning. So here's the key, and I'm going to get rid of the hash rocket. So this here, last name colon, is not technically a symbol, but it's converted into a symbol. This is the way we indicate a key value pair that's the symbol last name and the string Hartle. So you can hit return there. You can probably just see visually that they're the same, but we can use the double equals operator, or the comparison operator, so h1 double equals h2, and that's true. So you can see that these things are exactly equivalent. As a final example, I'd like to make what's called a nested hash. So let's start with an empty hash called params. We'll see later in the tutorial why I'm calling it this. This is short for parameters. There it is, an empty hash. And now I'm going to say params of the symbol user is equal to another hash. And I'm going to define it literally here. Remember, I could do something like this. I'm going to have a name. I could do this hash rocket, but it's more conventional nowadays to do name colon. So that's the full name, and then I'm going to have the second part of the hash be email. I said second part, by the way, that there's no ordering with hashes. At least there's nothing fundamental about the order. So with an array, there is an order. It's laid out 0, 1, 2, 3. There's no order here with a hash, though. If you print out a hash, in principle, it could be permuted. It could be name, then email, or email, then name. I think as of Ruby 1.9, it actually does preserve the order, but it would be foolish to rely on that. So what we've done here is we've assigned to a key in the params hash another hash. So let's take a look at what params is. So params is the user key and then another whole hash. So you can pull out params of user like this. And if we want the name of the user, for example, we can do this. And similarly for email. These sort of hashes of hashes, or nested hashes, are very commonly used by Rails. So it's a good idea, even at this early stage, to start getting a sense of how they're used. We saw before how we could use blocks, along with things like each and map, in the context of arrays and ranges. The same sorts of methods also work with hashes. So let me give you an example. Here's a literal hash. It's called flash. Again, this is strategically chosen. We'll be talking about a hash called flash later on in the tutorial. So the key success will be associated with the string it worked. The key danger will be it failed. So let's iterate through this thing. We saw before an example with arrays where there was only one variable associated with the block. But in this case, there are two variables because the hash here consists of key value pairs. So this is the key value. Oops. Oh, I just mistyped it. Key value. Oops, did it again. There it goes. Flash.each do key value, and then let's just put as key, and then the key has value. I'm just interpolating these things in. We'll see in a moment this isn't exactly what I want. So you can see here it says key success has value, it worked. Key danger has value, it failed. But what I'd really like to say is key colon success, because again, you can see here that in fact it's a symbol. And value, quote, it worked, because it's a string. So there's a way to arrange that. There's a way to make Ruby have the literal representation of what the object is. So what's going on here is it's just calling 2s implicitly. It's doing something like this. So success.2s is just the string success, so that's why this is showing up here. But there's another method that is more useful in our context called inspect. So you can see this is what we want if we actually want to print out something that represents this, say, as a symbol. Let's try that again. And there we go. That looks more like what we were expecting. Key, colon, success as value, quote, it worked. And then similarly for the other case. Because this is a fairly common case, there's a shorthand for printing out the inspect version of something. So here I did success.inspect. We can do put s success.inspect. This is basically equivalent to writing this. The only difference is that put s returns nil, whereas the p method returns the symbol. So we could also do something like this. Contrast that with this, which is not nearly as nice. Oh, it's actually the same. Ah, there we go. There's an example of where they're different. So p of flash.keys shows that the keys are these symbols, whereas if we put s flash.keys, then it puts them out like this. So flash.keys is an array. And as you might expect, there's the corresponding array, flash.values. With our newfound knowledge, let's take another look at the style sheet link tag helper in the site's application layout. See if it makes any more sense. Well, we can now identify this as a method. This is a helper method defined by the Rails framework itself. We've got single quoted strings in here. They could just as easily be double quoted strings. Now, this here, though, this looks like a key value pair, right? Media colon all. And this also looks like a string key with the hash rocket and the true value. But there are a couple of things missing. One is that where are the parentheses here? If this is a method, why isn't it like this? And the answer is we could do this. This will work. But parentheses are optional in Ruby in the context of function calls. And you might think, well, this thing here looks like it's a hash. And it is. We can do this. This is now equivalent to what we had before. So what's going on here is that there is an optional argument in the style sheet link tag method that's a hash. And in this context, in the context of this optional method, you can leave off the curly braces. This is a very characteristic property of Ruby, that Ruby is quite flexible and malleable when it comes to syntax, which can be a little confusing sometimes because often there are multiple ways to write the same basic idea. But it allows for a much more natural looking code in many contexts, including this one. Of course, style sheet link tag, as you can probably infer, returns a string, and because of this open angle bracket %equals, that gets inserted into the template. So let's take a quick look at the results of style sheet link tag. Let's fire up a server. Take a look at the source, and we're looking for the style sheet link tag. That is this right here. Now this looks pretty complicated. There's a bunch of stuff here. There are a lot of things in this little code snippet that don't really make a lot of sense, but that's the beauty of having a helper. We don't have to worry about those details. Rails is taking care of those details for us. I've mentioned a couple of times that everything in Ruby is an object, and in order to understand better what that means, we're going to take a look at Ruby classes. This will let us define some objects of our own. In particular, a Ruby class can be instantiated to create objects. If you're new to object-oriented programming, that might sound like gibberish though, so let's take a look at some concrete examples. We'll start with the idea of a constructor, which is what's used to make a new object. We've seen examples of literal constructors like this, where you just put a string of characters inside of double quotes or single quotes. That gives us a string. We can ask the string object what kind of class it is, and it's a string class. We can also use a named constructor. Instead of the literal constructor, we can actually use the class name, and then the new method. So this is what's used to instantiate a new object. String.new is foobar. So we can see that using the named constructor is just the same as using the literal constructor. And arrays work the same way. Do array.new. This is the array class, and then we can give it an array. Of course, there's no reason you would really do this, right? This doesn't make any sense. This is just an introduction to the idea of having a named constructor. But in real life, you would never do this. There is a case, though, where you would do this sort of thing with a hash, because hashes work in a different way. Do hash.new. This is not going to instantiate a hash with the value of 0. That's not even a hash. This returns an empty hash. You can see h is just the empty hash. What this does is it returns a default value of 0. The ordinary behavior of hashes, if we just make another hash, is to return nil. So the argument of hash.new is not, in fact, a hash, in contrast to the string here and the array here, but rather is the default value of the hash if the key doesn't exist. We're never actually going to use this fact in this tutorial, but because it's a little counterintuitive, I thought it was important to mention. By the way, we can see here the two principal kinds of methods in Ruby. There's a method here, class. This is being called on an object, sometimes called an instance of the string class. So this is an instance method. In contrast, new is being called on the class itself, and that makes it a class method. We'll see many more examples of instance and class methods throughout the rest of this tutorial. In order to understand how Ruby organizes classes, it's helpful to look at what's called the inheritance hierarchy. We've seen a couple of examples of inheritance before in the context of model objects and controllers. So in this case, I just want to look at one of the default classes in Ruby, namely a string. As we've seen, the class of the string is just class string. But if we want to see what string inherits from, we can use another method called superclass. We can chain this. You can see that the string superclass is object. There's actually one more. There's basic object, and then at the end of that is nil, which means that there is no superclass for basic object. So let's take a look at a diagram that helps visualize this. This is the inheritance hierarchy for string. We can move this over a little bit so we can see everything there. So string inherits from object, which inherits from basic object. So this is what it means to say in Ruby that everything is an object. Everything ultimately inherits from object and thence from basic object. What this means in practical terms is that methods like the nil question mark method, which are defined in object, are automatically available on instances of the string class. That's the basic idea behind inheritance. To understand classes better, let's make some of our own. I'm going to make a word class. You can see that classes should be capitalized. And I'm going to define an instance method. It's going to be a Boolean method called palindrome that takes in a string and returns true if the string is a palindrome, that is to say if it's the same forwards and backwards, and false otherwise. And the way to do that is to say, well, is the string equal to its own reverse? So let's instantiate a new instance of the word class. W is a word. And let's see if, see if foobar is a palindrome. It's not. What about the word level? It is. Look at that. Now in this context, you might wonder, why is it that we're passing a string as an argument? Why not just make a word a string so that we could then instantiate a new word object and then just call w.palindrome without this part? Let's see how that might work. So what we want is for a word to be a string. Another way to say that is a word is a string. And when you have an is-a relationship like that, it's a case for inheritance. Now in this case, what we need to do is get rid of the current definition of word. There's actually a way to do this right in the console, but it's a little advanced, so I'm just going to show you the easy way, which is to exit. You can do exit, just type it out, or Control D, which is what I did there, and then restart it. That cleared out our previous definition, so now we can do class word. Instead of just by itself, we're going to say that inherits from string. I'll put in a documentation comment. So this is now a string, this word. I mean, words are strings. So you might ask, well, if we don't have an argument, if we don't have like a string variable, how do we compare the string to its own reverse? And the answer is that inside of this class, we have access to the string, which is to say the word, through the variable called self. This is a special variable, self, and we can say, well, is self equal to its own reverse? If that's true, it's a palindrome. So let's test this out. We can say s equals word.new. We can instantiate it with, remember we saw how to do string.new and then a literal string. Let's try this here. Now that's false. So you can see now that the s here is actually a word. So in fact, let's call it w. Let's do this. And let's make something that is a palindrome. We saw that level is a palindrome. So inside of this class, self is level. It's this string. And in this context, we can ask what class w is. It's a word. And its superclass is string. So it's inheriting from string, and indeed it has the following hierarchy. So word inherits from string, which inherits from object, which inherits from basic object. So you can see this is just the same, except we've added word at the bottom. By the way, inside of a class like this, you can actually omit self dot. We need self here because otherwise there's no way to know what we're referring to, but we can actually omit self dot and just say reverse, so this would work too. Actually, it might complain here that it already exists. No, looks like that worked. Oh, it's because, I think it's because this is exactly the same. Before it wouldn't have worked. So now we can do this. There we go. So the self dot is implicit when it's an instance method like reverse. Of course, words are different from strings in that they have this extra method, the palindrome method, but because of inheritance, words have all of the normal string methods as well. So we can do something like this. Do the length. We can calculate the reverse, and so on. And in fact, the reason that we were able to use reverse inside of the palindrome method is because words are strings. Now there's one other thing that might be bothering you, which is that, well, words are strings, but what about doing something like this? It'd be really nice if we could call palindrome on a literal string like this. But that doesn't work because strings don't have a palindrome method. So this is something that distinguishes Ruby from a lot of other languages, which is that you can actually open up built-in classes like string and add methods to them. Now obviously this is a really dangerous thing potentially. You could do crazy things like redefine plus to be multiplication for fixed nums, so that any time someone did 2 plus 3, it came out 6 instead of 5. So this is the sort of thing, it's one of these great power, great responsibility situations. So we're going to very delicately modify the built-in string class by adding a palindrome method. So let's try that. This is the built-in class, class string. Now let's define our palindrome method. So remember, self is available. Self is equal to its own reverse. We can leave off the self dot there. So this could be self dot reverse, as we just saw. But now this self, this isn't a word. This is a string. We're just adding palindrome to the string class. So let's see if that worked. Oh, why didn't that work? Oh, I see what happened. I called string question mark. That was stupid. So let's call palindrome question mark. Foobar.palindrome question mark is false. What about deified? You might think, no, that's not a palindrome, but it is. So this is really amazing, that we can actually open up a default Ruby class and add a custom method like palindrome so that we can call it on a literal constructor like this. And so you can see that the distinction between built-in Ruby methods and methods that we add is in a sense artificial. And it's this kind of flexibility that allows Rails to add all kinds of things to vanilla Ruby, and yet everything feels like a seamless whole. So let me give you one example of that. This is the blank method. It's useful to know if something's blank. So the empty string is blank, but so is just a bunch of blanks, a bunch of spaces. But this is in fact not part of Ruby. This is added by Rails, and because the Rails console adds a bunch of the Rails extensions, we have access to something like the blank method. You might suspect that blank is added to the string class, but in fact, nil is also blank. So it's actually added all the way down at object. I mentioned before that we've actually seen some examples of this inheritance, so let's take a look at those again. Take a look at the static pages controller. Remember here, static pages controller is a class, and it's inheriting from application controller. So let's take a look at the inheritance hierarchy of the static pages controller. We can actually instantiate a new controller right here in the Rails console. What's its class? Well, you can probably guess. It should be this. It is. Superclass is application controller. That's this inheritance hierarchy right there. And if we look at the application controller, that inherits from action controller base. So if we call superclass again, that's what we should get. Indeed. Let's just keep going. That inherits from action controller metal, close to the metal. That inherits from abstract controller base. How far does it go? Aha! Now it inherits from object and basic object. So the inheritance hierarchy of that looks like this: static pages controller, application controller, action controller base, action controller metal, abstract controller base, object, basic object. So you can see that the same basic things happen at the top of the hierarchy right here: basic object, object. But then there's a lot more structure added by these intervening classes. Now if we look back at the controller itself, you can see that, well, it's got these methods. Can we do this? Controller dot home. Can we do that? And the answer is yes, it actually works. It exists. Now it returns nil, but it didn't give us an error. Right? If we did this, that's going to give us an error. But this actually works. It returns nil. But that's not what calling the home action does in the context of a Rails application. Right? If you call the home action, what happens is that it renders the home template. And so this is why it's actually not all that useful to be a Ruby expert before you pick up Rails. I mean, it certainly helps, but there's a lot of work to become a Ruby expert. And it's just not important for a lot of the things you do in Rails. And in particular, if you know a lot about plain Ruby, it can be really confusing because this kind of behavior, that rendering a template automatically, is not at all what you would expect based on a naive understanding of Ruby. We saw an example of a simple class in the context of Word, but now I'd like to make a slightly more complicated class, in particular one with its own constructor, as a final exercise in this lesson. Because it's a little more extensive than the ones we've made before, I don't want to do this in the console. I'm going to define a new file. We're just going to put it in the home directory of the application. So open up a new terminal, cd sample app, and I'm going to touch example user. This is just an example. We're actually going to delete this once we're done learning from it. All right, so what I want to do is define a user class like this, capital user. And I'm going to give it two attributes. Actually, let's put an end so it's valid, just to get rid of that. You can see here, it's just giving me a complaint that there's a syntax error. So let's make a couple of attributes. The way to do this in Ruby is with what's called attr_accessor. Accessor means that we can both read and write from these attributes. In some other languages, this might be called getters and setters. So here's name and email as symbols. So these are the two attributes I want this user to have. And then I want to be able to call user.new. And it's kind of weird, actually, that instead of defining a method called new, you define a method called initialize. I'm not sure why they designed it this way. But initialize is the way you do it. And we're going to give it an optional attributes hash. It's optional because I'm going to give it a default value of an empty hash. And now I'm going to define two instance variables. And I'm going to pull out the attributes that are given. Now, these @name and @email variables will be available anywhere else in the class, anytime we're talking about a user instance. In particular, I'm going to define a formatted email method that returns one of the common formats for email, which is the name and then the email address surrounded by angle brackets. Let's do this. And here we can interpolate in the instance variable, name, and then in angle brackets, email. All right, let's see what effect that had. Go to our console, and we're going to require this. And the most general way to do this is to require it relative to the directory it's in. So this is // dot is the current directory, and then slash is just giving the file path. So it's / example user. And we don't have to put the RB on it. So true means that it required it correctly. So let's see how that worked. We can just give user.new no arguments. So that means that the attributes is going to be just the default, which is the empty hash. So that means that @name and @email should both be nil. And we can pull out that value by doing example.name. So what this is going to do, it's going to look for an accessor. It's going to say, is there an accessor? Yes, there is. Is there a corresponding instance variable @name? Yes, there is. What is its value? It's nil. So that's what got printed out. Same for email. Now, because this is attr_accessor, we have both the getter method, which lets us get the value, and a setter method, which lets us assign. So let's do this. Example.name equals example user. And let's assign the email address too. And now we can look at the formatted email. And it has this nice format. We can also instantiate a user with attributes that are given as part of new. So let's do that. User.new, and we can give it an attributes hash. Name, my name, and then email, my fake email. You can see here @name. This is from this here, this assignment, and @email. And let's see if the formatted email works. It does. Now note that because this was an optional argument, it's actually just if the hash is the last argument, I could omit the curly braces. So this is exactly the same as if I put in curly braces here, like this. But you would never see that in Rails code. No one ever puts the curly braces in unless they're absolutely necessary. This way of instantiating a new object with a hash of values is called mass assignment, and it's a very common way to create a new object in Rails. All right, that concludes our overview of the Ruby language. Focusing on the parts of Ruby that are most important for Rails, we've actually made one change that we want to keep in this lesson, which is the definition of the full title helper and its associated changes to the test and to the home view. So let's commit those. And we can see here that we've created an example user which we don't want anymore, so I'm just going to remove that. I don't have to do git rm there because we never added it to git. You can see that the application helper has, well, actually we can take a look at this. We could do git diff to see what changed. You can see we added the full title helper and then we used it, and we also changed the test and we got rid of this provide line. So this is a list of the changes we made. So let's commit those changes. Oops. Actually, you know what? I don't need to do git. I was going to do git add-a. Well, might as well. It's the same thing. You could also do git commit-am since we didn't actually add any files. We can also push this up to Bitbucket. And we can deploy it to Heroku. Of course, we didn't really change anything, but I still think it's a good idea for the master branch to be what's currently deployed. And in this context, I think it's really a bad idea to deploy without running the test, so let's do that. All right, the tests are passing, so now we're ready to deploy. We'll start putting our newfound Ruby knowledge to good use starting in the next lesson, where we'll return to the main sample application that will be our main occupation for the rest of the tutorial.